Hi everyone. So in last class what we have discussed? We have discussed about Huygens principle, isn't it? What are the important points? 2 points are there. So in today's class what we are going to see means how you can explain the phenomena of reflection using Huygens principle. That means using wave equations or wave principle we are going to explain reflection using Huygens principle. Actually, we are going to explain two phenomena. First one is law of reflection, next one refraction. It's already explained in ray optics what is laws of reflection and what is laws of refraction. Do you remember what are laws of reflection? What was it? That's it. Angle of incidence, angle of reflection are same. Incident ray, reflected ray and normal at the point of incidence all lay in the same plane. These are the two laws of reflection, isn't it? So out of this we are going to see the law, that is angle of incidence equal to angle of reflection. I is equal to R. That is, suppose there is a boundary here. When light ray is incidenting like this, and here I am going to draw a normal also. Okay. So this is incident ray. This is called incident ray. This is called reflected ray. This is reflected ray. Okay. So the angle between the incident ray and the normal is called angle of incidence, I. The angle between the reflected ray and the normal is called angle of reflection. So according to the law of reflection, what is it? Angle of incidence is equal to angle of reflection. This we already saw in ray optics, or in lower classes we already seen that. The same thing we are going to explain using Huygens principle. Okay, let us see how it can be explained. For this, diagram is very important. How to draw the diagram, that's very important. Let us see. So what we are going to see means, here we are going to see the incident rays. First one you can see IA. This is the incident ray here. This is the boundary, the surface of reflection where the reflection is taking place. Okay. So this is the surface, reflecting surface. So one ray is incidenting like this. Okay. When one ray is incidenting, another ray again it's parallel to this ray. Parallel to this also incidenting at this point. Clear? So these two lines represent the incident rays. Okay. Now next we had to draw about the reflected wavefront. How the reflected wavefront can be drawn. We already seen in the last class. Suppose the velocity of light in this media is V. So you know, distance traveled by time is equal to velocity generally. So what is the distance traveled? Velocity into tau. Now I am going to take the time as tau. Okay. So if you have a parameter like velocity into tau, if you take that value and draw a arc, then if you draw different points and if you combine all these tangents, you will get the reflected wavefront. That's what we discussed in last class. So how to draw this? See this one? Here incident ray is coming. Suppose we want to draw, we have to draw a reflected wavefront after a time tau. I am considering the time tau. Okay. So what happening means incident ray it reaches the point A. Okay. So I am taking V into tau and from this I am going to draw what? An arc. So one process over. The rest means again like this next ray will incident like this. Again you can draw V2, next ray V2 like that. Okay. So what happened means you can see different arcs. And if you combine all the things you will get a new line here, isn't it? New line. This is the joining of all the tangents. So this is called reflected wavefront. It is nothing but reflected wavefront because we got After reflection only this one we got. So what we did, V into tau we made, and we just plot the arcs and draw, combine the tangents, you will get another reflected surface, that is reflected wavefront. Is it clear? So this is how you can draw the reflected wavefront. Another thing, when this ray is coming here and reflection is done, and this distance is nothing but V into tau, as we seen already. At the same time, this ray will reach here only. Note the point, very important. When the incoming ray like this is reflected to V tau, this will reach here only. That means this is the time V tau. At this distance, the second ray is just touching the surface. So here reflection happening, but this one it has to travel more because it's just like that, it is falling. So V tau time it has to touch here. Okay, clear? Now next we are going to see the angles of incidence and angles of reflection here. Let us see. Normal thing only, we have to draw the normals and see the angles. Let us see. Here you can see it's incidenting. This is the normal here, this is the normal here, and angle of incidence I marked with the normal. Okay, same thing what we did. And you can see angle of reflection normally. What is it? R. Why it is angle of reflection means it is the reflected wavefront, no? So this is the ray. Reflected wavefront, always the ray and wavefront are perpendicular. Think like that. Ray and wave is always perpendicular. So this is the ray which is perpendicular to the reflected wavefront. So definitely this angle will be angle of reflection. Ray is always perpendicular to the wavefront. Okay, that is how this is I, this is R. Ray and wavefront are perpendicular. Now see, if this is I, what about this angle? Just see. If this is I, this is ray, another wavefront you can see, not a wavefront, this line, this is perpendicular. This line and this one is perpendicular. If this is I, what about this angle? It is nothing but 90 minus I. Am I correct? 90 minus I. So incident ray is making 90 minus I with this. This is I, this is 90 minus I. So if this is 90 minus I, this angle definitely will be I, because 90 minus I plus I, what is it? 90. This becomes 90. So this is 90 minus I, this is I. Then only it is possible. Is it clear? Similarly, you can explain the same thing here also. This is R. Again it is incidenting and it is reflecting. Here also you can draw the normal. This is I, this is R, and you can see here this is R, isn't it? So what about this angle? It is nothing but 90 minus I. Now see, this and this, they are perpendicular to each other. If this is 90 minus R, this one is R. Is it clear? See, you can see the normal and this is perpendicular like this also. Okay, the normal and this is perpendicular. If this is 90 minus I, this is I. Similarly, if you look closer, this angle is R. So this one will be 90 minus R and remaining this angle will be R. Is it clear? From the diagram itself you can understand. So we got these two angles. This is I and this is R we got. Okay. So like that you can explain how that incidence and reflection came. Now I will rub that in order to avoid the confusions. So we explain how that I and R came from this diagram, isn't it? Yes. Now let us see. Now we got this diagram, isn't it? This is I, this is nothing but 90 minus I, this is I, this is R, 90 minus R, this is R. Okay. Why this is R means incidenting, normal and reflecting. So this is angle of incident, this is angle of reflection, like that. Okay. So what we got means you got two right angle triangles here. Can you see? Triangle A1C and triangle ABC. Can you see? These are the two right angle triangles formed. Okay, A1C and ABC. If you look at this right angle triangle, you can see that AC is a common side. Can you see? A1C ideyum, ABC, AC is the common side. And you can see this is V2, we already saw. This is V2 and this is also V2 because V2 time it is touching. Okay, so this is also V2, this is also V2. So what is happening means it is obeying the congruency RHS. According to RHS rule, that is right angle triangle property, these two triangles are congruent because for a right angle, if one side is common, other side also equal means they are congruent. RHS. Okay. Congruent means the corresponding angles are equal for a pair of congruent triangles. Now, what are the corresponding angles here? Let us see. This is V2, this is also V2. So, just take the opposite of that side. That will be corresponding angles only. This is V2, this is also V2. If you take the opposite angles, what is it? Idukku opposite the idu, isn't it? Idukku opposite the idu, I. So, both should be equal because it obeys RHS principle. Okay. So, opposite to this is R, this is I. What does it mean? According to the RHS congruency, angle I is found to be equal to angle R. What does it mean? What is angle I equal to angle R? We already seen that is nothing but the law of reflection, isn't it? Angle of incidence equal to angle of reflection is nothing but what? Laws of reflection, one of the law of reflection. Is it clear? Okay. So, what we have proved? It's very easy, provided if you draw this diagram properly and if you are able to explain it. The steps are very less. Okay. So, what you got? Angle of incidence equal to angle of reflection. It can be proved using Huygens principle. We used only the wave theory, the idea of wavefronts only, isn't it? And from the congruency, we understood that angle of incidence equal to angle of reflection. That's all. Hope you all like this video. Like, share and subscribe. Okay, thank you.